Alright, so we've been talking about solving these trig equations. To be able to solve these trig equations, pretty helpful to know your triangles, right? Yep. Your 30, 60, 90, 45, 45, 90 triangles, right? 45, 45, 90, what are the side lengths, guys? Good. And 30, 60, 90.
2x,
X, 2x, and x radical 3. Okay? Alright, so you kind of got to have those down, but if you have those down, most of these values are going to come pretty easy for you. Alright? So maybe we'll do just a quick review too on what we memorized as far as 30s, 45s, and 60s. Sine of 30? Half. So cosine of 30? Root 3 over 2. Sine of 60, root 3 over 2. Cosine of 60, 1/2. Okay? We got our 45s done. Sine of 45? Root 2 over 2. Cosine 45? Root 2 over 2. Tangent 45? 1. Okay? Then we got to get our tangents done. Tangent of 60? Root 3. Tangent of 30? Root 3 over 3. Okay? Not bad. Okay, we're definitely doing better. Alright, so with that, when you see this equation right here, the tangent of x equals root 3 over 3. Okay? What sort of reference angle would you be working with?
30.
60, 30?
30.
Which one is it?
30.
Let's look. Okay? 60. The tangent of 60 would be opposite over adjacent, right? So tangent of 60 would be x root 3 over x, which would just reduce to root 3. Okay? So it's not a 60, it's a 30. Remember on the 30, it's got the extra 3 in there. Alright? Tangent of 60 is root 3, tangent of 30 has the root 3, but it's over that extra 3, goes with the 30. It's kind of how I remember it. Okay? So I'm working with a 30-degree reference angle. So your answer is going to be some angle that has a 30-degree reference angle, either in quadrant 1, 2, 3, or 4. Okay? Where is tangent positive? First quadrant. Everything's positive in the first quadrant. And the third. Why is tangent positive in the third? Everything's negative. Negative divided by negative, right? Because down in the third quadrant, y divided by x is a negative divided by a negative, which would make it positive, right? Okay? So I'm looking for 30-degree angles, 30-degree reference angles in quadrant 1 and quadrant 3. Quadrant 1's easy. What's that angle? 30. Quadrant 3, what would that be if you got a 30-degree reference angle? 210. Because 180 plus 30 more, got to be 30 degrees away from the x-axis. So your answer would be 210. So x equals 30 degrees and 210 degrees. Okay? That okay?
What do you mean on the top such that?
Well, are these the only two answers in the world?
No.
No. 30's an answer, 390 would be an answer, 750 would be an answer. I could keep going around the circle an infinite number of times. This is saying I only want answers between where and where? 0 and 360. It limits your answers, basically. So you don't have to write down an infinite number of answers. Okay, sine of x equals -1. This one's a little bit different. Is this a 30, 45, or 60-degree reference angle? Is sine of 30 equal to 1? Sine of 45? Sine of 60? So where must this angle be? If it's not a 30, 45, or 60, it must be where? It's a quadrantal angle, so it's a 0, a 90, a 180, it's on the axes. Okay? I'm hearing some whispers. Is it 0? No. Is the sine of 0 equal to -1? Why not? Why is the sine of 0 not equal to -1? Yeah, everything's positive, first of all. Okay, and specifically, sine is our what value? The second one, the y value, right? Okay, well, where is my y value going to equal -1? right down here at 270 degrees. That is your only solution. That is your only solution between 0 and 360 degrees. Yes, sir?
I was asking this because when it asked on the test, I wasn't sure since I was gone today, we talked about it, but when it asks for a reference angle, that's a specific value, right?
Yes, a reference angle is always an angle that's between 0 and 90 degrees, and it tells you how far the terminal side is away from the nearest x-axis.
Okay, so if it's like on the axis, then it's 0?
If it's on the x-axis, the reference angle would be 0, yes. If it's on 90 or 270, the reference angle would be 90. Okay. Doesn't matter which way you go.
Right, yeah, that was confusing since I was gone today, we talked about that.
Yep. And it's always a positive. Even if the angle's down here, the reference angle is still just a positive measure. So in other words, how many degrees would you have to rotate to get to the nearest x-axis is basically what the reference angle tells you.
Alright.
Alright, last one. Cosine of x equals a half. 60 degree reference angle because cosine of 60s are halves. Where is cosine positive? First and the fourth. Okay, cosine is your x. Cosine is going to be positive to the right. So I'm looking for a 60 degree reference angle in quadrants 1 and 4.
330.
Quadrant 1, 60 degree reference angle.
60.
60. Quadrant 4, 60 degree reference angle. 300. Yep.
Yeah.
300. Right? I'll show you. Right? It's got to be a 60 degree reference angle, right? So that would be how far? 300 degrees because it's 60 degrees shy of all the way around the circle. So 360 minus 60. Questions? Yes? No? Okay. Alright, pretty good. So this is solving trig equations. That was kind of half of our learning target today. I can solve basic trig equations. Okay? And for right now, we're just answering them for x values between 0 and 360 degrees. Okay? These will show up again, especially once we start working with radians. Alright? But you'll have the general idea now, which is good. Teach you degrees first because you understand degrees a little bit better.
What if we know it if we write it out, but it's not
Okay. You'll get better at it. There's already been improvement from yesterday. Okay? So, you're alright. Okay. Next, simplifying trig expressions. Okay? So we're going to simplify this right here. What's the sine to the negative 1 power mean?
The inverse is
Inverse of sine. And what do inverses help you find?
the opposite.
Not quite.
Oh,
The angles. Inverses help you find angles. Okay? So when you see the inverse sine of 2/3, what you're really finding is the value of some angle whose sine is equal to 2/3. Okay? You can do this on a calculator, but you're not going to need to. Alright? The inverse sine of 2/3 is really just helping you find the value of that angle right there. Okay? The inverse sine of 2/3. So just this part right here, you would do this on your calculator, which you don't need to. Okay? But if this was the problem, if I said, what's the inverse sine of 2/3? Then you could go to your calculator, type in inverse sine of 2/3, and it would tell you the value of this angle right here, because that's what inverses do. They tell you the value of an angle, the degree measure or radian measure of an angle. Okay? Yes, no, I get that with inverses. Want to see another picture to support that? Okay? Okay? So, this part is going to help you solve for that angle right there. Okay? So the answer to this is some angle. It's the value of theta in that picture. But now what is this telling me to do? Take the sine of that angle, right? Well, don't think too hard. What's the sine of that angle? 2/3. Guess what the answer to this right here is? 2/3.
might kind of sound kind of silly,
No.
but like the sign, like would it distribute, quote unquote, to the inverse sign, since there's parentheses and all that, and they would just cancel out, and you'd be left with 2/3?
Exactly.
Okay.
Okay? I didn't even have to go through that thought process there, because yes, doesn't this and this, don't they cancel each other out? Yeah, so your answer is 2/3. But I wanted to show you a picture, because, now I'll teach you what this is here in a second. But let's say this would have said tangent inverse sine 2/3. Then they don't cancel each other out, and then we go back to the picture. But I wanted to show you the picture idea to help you understand that. Remember, this is finding the value of an angle, but I don't even need to find the value of that angle, because I'm just going to find the sine. I'm going to go back and find the sine of that angle. So, all right? A lot of times, you instead of seeing tangent to the -1 or sine to the -1, you'll also see what the books will write as arctangent. Okay? Arctangent is really inverse tangent. It's just a different way of notating it. Okay? Arcsine is really inverse sine. It's a different way to help you figure out, or I don't know, I guess I don't even really know why they write it that way. It's just like we've seen it a lot. All right? It shows up on standardized tests once in a while. Arctangent, inverse tangent, they essentially mean the same thing. All right? For what you need. So don't let that really fool you there. My eraser's gone. All right. So here, arctangent, 4/7, and then I'm going to take the cosine of that. Okay? Arctangent of 4/7 is going to help me find some angle, remember? Okay? This is going to help me find the value of an angle. But then I'm going to take the cosine of that angle. Okay? I think it's helpful to draw a picture. We know that this angle has to have a tangent value of 4/7. So how could I label this?
Opposite over adjacent, so.
So 4/7, right? So if I would do arctangent of 4/7 on my calculator, that would give me the value of this angle right here. Okay? Do I care about the value of that angle? No, because I'm going to go find the cosine of that angle. So what's the cosine of this angle? 7 over something, right? Could we figure out what that something is?
Yeah.
Pythagorean's theorem. 7 squared plus 4 squared, so 49 plus 16 is 65. Square root to 65 can't reduce, so it just stays square root of 65. So now I know then that the answer to this will be 7 over root 65, 7 root 65 over 65. Okay? Alright, you try the last one. Go. Find the tangent of some angle whose sine value is equal to 6/7. Leave your answer in simplest radical form. What's that? Okay. 6 radical 13 over 13.
Wait, how how do you know what side is opposite?
Well, it says the sine of that angle has to be 6/7.
Okay, I
Sine,
didn't know, yeah, I didn't know if you were going with tan or something.
this says the arc sine is of 6/7. So that's saying some angle has a sine value of 6/7. Once you figure out what that angle is, well, we're not actually going to, but draw the picture so that angle has a sine value of 6/7, then find the tangent of that angle. On standard 3, advanced math standard 3 practice, I'd like you to have problems 1 through 6 done for next week.